Hey everyone! Today we're going to be solving the 2020 AMC 12A problem number 10. It is a logarithm problem. There is a unique positive integer n such that log base 2 of log base 16n is equal to log base 4 of log base 4n. What is the sum of the digits of n? As you probably know, if you have log base a of b equals to c, this basically just means that a to the power of c equals to b. Another thing that we might notice when we look at this problem is that, we have our log base 2, we have our log base 16, and then like several log base 4s. One thing we might notice pretty immediately is that all of these are a base of something that's a power of 2. Like 2 is just, 2, 16 is 2 to the power of 4, and then 4 is 2 to the power of 2. In general, if you see a log problem and like an equation with things on both sides, you want to try to get them into the same base because that's just going to be a lot easier to solve for and like compare the sides to one another. So it looks like because everything is to the power of 2, we'll be able to bring everything into log base 2 pretty easily. And to use that, we're going to have to use the log change of base formula. The log's change of base is basically a way for you to convert any logarithm into whatever base you're looking for. So let's say you have a log like log base m of n, but you want to write this in terms of log base x. You can just always add that in. So the way you would do that is that this is equal to log base x of n divided by log base x of m. So basically now you have this expression where everything is in terms of log base x instead of log base m, which it was previously in terms of. So that's one way of doing it. Obviously, another way to rewrite the exact same equation is that log base m of n is equal to 1 divided by log base x of m times log base x of n. All right, so let's now change the left hand and the right hand side to reflect this and like be in terms of log base 2. So let's start off with the left hand side. So on the left hand side, we have log base 2, which is already in terms of log base 2. And then you have log base 16n. So now we want to get that log base 16n to be in terms of log base 2. And if you remember, we can basically rewrite that as 1 divided by log base 2 of 16 because, in the equation where log base 16n, 16 is like m over here, and then times log base 2 of n. So that's that one. You might know pretty quickly after looking at this that log base 2 of 16 is equal to 4 because 2 to the power of 4 is equal to 16. So log base 2 of 1/4 times log base 2 of n is what this is. So that's the left-hand side. Now let's move on to the right-hand side. So we have log base 4 of log base 4n. So if you remember, this is the same thing as 1 divided by log base 2 of 4 times log base 2 of this part right here, which is log base 4n. Again, there's a log here that should be fairly obvious, which is log base 2 of 4. 2 to the power of 2 equals to 4. So 1 divided by log base 2, 4 is the same thing as 1/2. So we have a half times log base 2, log base 4n. Let's now try to simplify this 4 to be in terms of base 2. So this is the same thing as a half times log base 2 of 1 divided by log base 2 of 4 times log base 2 of n. And again, this 1 divided by log base 2 of 4 is the same thing as a half. So this is the same thing as half times log base 2 of a half times log base 2 n. Let's now move on to another thing that we should know about logs, which is that if you have a log base x of a times b, this is the same thing as log base x of a plus log base x of b. And so that's how we're going to deal with the fact that we have two things here, we have two things here. So now let's use this equation to actually write out these logs. So on the left-hand side, we have log base 2 of a 4th plus log base 2 of log base 2n. On the right-hand side, we have half log base 2 of a half plus a half log base 2 of log base 2n. Log base 2 of 1/4 should be fairly obvious again because 2 to the power of negative 2 equals to 1/4. 2 to the power of negative 2 is the same thing as 1 divided by 2 to the power of 2, which is a fourth, which is how we know that. So this is just negative 2 plus log base 2 log base 2n. On the right side, one thing we know about that is that log base 2 of a half is the same thing as negative 1 because 2 to the power of negative 1 equals to a half. So basically here we have this we have a half here times negative 1, which is the same thing as a negative half. Plus, again, 1/2 log base 2 log base 2n. So now we basically have these two sides, the left-hand side and the right-hand side, as simplified as we can get them without actually solving for n yet. So let's set them equal to each other and see what we can do. So the way we write this out with the left-hand side and the right-hand side simplified is that negative 2 plus log base 2 of log base 2n is equal to negative half plus half log base 2 of log base 2n. Right? So one thing we might notice here is we have some like terms. We have a negative 2 here, and we have a negative half here. So let's just add 2 to both sides. So now we have log base 2 of log base 2n equals to 3/2 plus half log base 2 of log base 2n. Now another thing we notice as a like term is that log base 2 of log base 2n is here, and there's also log base 2 of log base 2n here. And if we want to set them equal to one another, we could basically here there's a half and here it's a whole. So we can actually subtract from both sides. Let's just say we subtract a half log base 2 log base 2n from both sides. So what we're going to end up with here is we're going to have a half of log base 2 log base 2n equal to 3/2. Let's now multiply both sides by 2. That's another simplification we can do pretty easily. So we do log base 2 log base 2n equals to 3. So if you remember from our first log rule, this equation basically means that 2 to the power of 3 equals to log base 2n, right? Because when you look at a logarithm, this to the power of this equals to this. So that's why we know that 2 to the power of 3 equals to log base 2n. Now, 2 to the power of 3 equals to 8. So 8 equals to log base 2n, right? And that means that n equals to 2 to the power of 8. Because, again, same log problem, 2 to the power of 8 equals to n. So n equals to 2 to the power of 8. And 2 to the power of 8 is 256. And then they asked us, if you remember, for the sum of the digits of n. So that's just 2 plus 5 plus 6, which equals to 13. So the answer is E.